Alright, welcome back to another video on Node.js specifically. So what I'm gonna do today is a quick recap about Socket. Okay? So especially with Socket, which is a very interesting and exciting topic for me at least, and the fundamental of the internet. So we start here of looking and how can we build a chat application with all the things that we already know, right? Especially with the HTTP protocol. So if you want to send a message, you use a post request. If you want to receive a message, you use a get request. Okay. But what about data that is outside of our control? So for example, data that our friend create. And the other question is, when do we know, or how do we know when to fetch data specifically? And data that it is outside of our control, data that is or might be in their own life cycle, for example, game, trading, or self-driving car. And most of the time we deal with this kind of situation with polling. Very quite effective approach. And this is send get request so often in a period of time, and when that time has passed, you send and you get request in a loop essentially. And this might be okay, for example, if you want to set a chat application. After all, you use this here. We use this set interval timeout to send get a request or to read data in a pull rate of 500 milliseconds. Again, for a chat application, that might be okay. After all, what you're doing is just adding 500 millisecond and 500 millisecond delay to all of your updates in the application. But for the real stuff like self-driving car, trading, or games, that might not be feasible. Again, for this use case as a chat app, might be okay. Another challenge is that here we are sending is 2 requests per second, 120 per minute, and this is just for one single user. So imagine that you have now 1,000 or 10,000 users. Or you need a very powerful server or a different approach. Sockets come to the rescue, and to understand Socket, I saw from the Merriam-Webster website the plain definition of socket, and they are just an opening or a hollow that form a holder for something. And in the case of data socket, is an opening in this computer system in which you can connect to send and receive data. So it's a holder for this type of connection in computer networks. So first, there are some couple concepts here, just for the sake of simplicity and the sake of the example. Computer systems. Computer systems are programmable machines that perform logic and arithmetic operations, and they are made of hardware, software, and it is peripheral, right? So you can interact with it. The OS is the main software, and it is peripheral. You might find, or here you can have is, or you should have, a keyboard, mouse, speaker, and a monitor. Okay. And when it comes to computer networks, which is a series of computers sharing resources located on or provided by network nodes, whether is a redistribution point, So for example, you have BGP, Border Gateway Protocol, that exchange routing data across different autonomous systems. Autonomous systems are interconnected networks that operate under a single admin domain. So for example, Google, Facebook, Cloudflare, Verizon. And a real life example of this is like, if you think that each person is a computer, okay, this is an analogy, and we are sharing this knowledge, music, insults, fluid, you name it, and we are located on a specifically geographical zone in the world, okay, maybe Argentina, Venezuela, India, China, Australia, Europe, or the UK or US, Mexico, and you belongs to a particular country. That's what it means, is to belongs to a, or to operate under a single domain, right? There's all of this interconnected server, which can be translated to all these interconnected people that share things, operates or are under a single admin domain or a single flag or name country. Okay, so that's one thing of this, or that's one of the network node, that it can be either a redistribution endpoint or a communicational endpoint, an IP address or an address that allows to identify a communication identity, such as a desktop, a server, firewall, a router, a switch, any other of the IoT devices. And this is something important because with all of these devices, right, and the socket or the internet is made of this billions and billions of socket exchange data, all of this opening exchanging data. So the basic building block is the IP socket, okay, and on top of that you have this datagram socket, where low latency is the most important factors, TCP, where reliability is the most important factors, and they are connection based, meaning that before you send or receive a message you need to connect, and also you can know if a message you send it was received or not. And on top of the TCP socket we have HTTP, which is the protocol. We already know that, and the WebSocket, which is a JavaScript features that allow two-way communication, real-time, with the user browser and the server. This is a concept that web developers or backend developers must be familiar with. So okay, cool. Because now then I look at the subtle difference between the socket and the pooling. So with pooling, we use is the HTTP protocol to send requests in a period of time. But with socket, it opened a channel of communication in real time, this two-way communication channel between the user browser and the server to allow this communication to happen. So this is something powerful because now the client doesn't need to figure out when to fetch data, and also we delegate all of that responsibility to the server to keep the client up to date. Again, this might be a particular trade-off, okay, for decentralized network. So far we have saw that yes, centralized network has been up to certainly point quite effectively and efficient when it comes to resource management, but there's a point where we need to delegate that to others. Okay, that's just a quick tangent. Uh, go back here, and then I look at the implementation of the WebSocket, such as or much like the HTTP, where you have Axios and no fetch. These are way of how to fetch data from the server. With WebSocket, we have is the WS uh, that only works on the server, and WebSocket on the browser. So the only trade-off is, or the couple trade-off is that, yes, first, if the browser doesn't support WebSocket, you can use that. That's one. And the other is you have now a mismatched API interface, and you need to juggling around between both of them. The the WebSocket on the client side have a different API interface as the WebSocket on the server side. And luckily for us, there is a convenient library that simplifies this and allow this real-time, bidirectional, event-based driven communication that works on any platform. And that's great. Socket.io allows to do that. And when I look at the anatomy of this, and the benefit is Socket.io not only provide a unified API interface, but also fallback. So we don't have to juggle in between different API set with different capabilities. We can only focus on write our code, so we can save brain power to do that instead of hunting bugs, which after all you're going to do that. But if this library can minimize 10 to 20%, you can save a lot of time, and that's actually what it does. And then is the fallbacks. So very important for production applications on commercial or corporate environments, where now the way it works is by when the client start a connection, it will attempt to make a WS or WebSocket connections. And if your browser is less than one of the, yeah, if the browser is those that belong less than 3% that doesn't support it, it will attempt to form a HTTP or a pooling connection, and that guarantee you that your application will work in any uh, platform. So very essential for production applications or production grade applications for corporate environment. With that, then after all of the theory, and then look at the anatomy of the client and the server. Okay, that even though that you have a single or a unified API interface, uh, each package, the client and the server, has different responsibility. The client only communicate to the server, and the server not only is responsible to keep the client up to date, but also to keep track of them, send message individually to a group of connected client, or broadcast to all connected client. And now, knowing this, then I look at how can we apply that on a multiplayer pawn game, something that the zero to mastery instructor uh, allows or we provide is the code that is responsible to make the multiplayer pawn game to work. Okay, and we focus is on the main concept of the code review from that multiplayer pawn code, which is all games have their own loop, something called game loop, right? Whether it's basic games like Minecraft or whether it's basic games like Minecraft or Tetris, to a more modern games like Minecraft or Fortnite, right? So then I look at what will be the responsibility that this server will have, okay, in terms of handling is some of the non-render logic, and then I look at how can I set up a server, a socket.io server, and for flexibility reasons we use the HTTP to do that, even though that is quite verbose. But again, flexibility and is what we want here, because we want is to create our application as much modular as possible, right? Following also the MVC pattern. And then I look at how can I connect to the socket.io server from the client. And listen to events. How can I listen to events? Handling events, and then more relevant to the multiplayer ponging, right? Like keep track of the paddle and on the ball, and also what happens when you disconnect. So by default, the socket.io will attempt to connect to the server unless the server explicitly unless the server explicitly doesn't allow it. Okay. Exactly. Unless the server explicitly won't let that happen. Okay. And then I use Express to now serve the content statically and see how can we easily create now an Express app uh, and a barebone Express app, all right, and define some basic middleware, especially for delivering static assets, right? The index.html. And then how can we integrate our Express app to the socket.io server? And here I abstract the socket.io code into its own file, socket.js, okay? And again, for versatility and to create our much more modularized server, we end up is organizing our server by first fetching each one of those packages individually, the HTTP, the IO, the socket.io, and then the objects that are relevant to this server file, the server.js file, the API handlers, the HTTP server, and the socket server, and the socket handlers. Okay, so here because we were using is just HTTP server to listen to our server and letting the Express app to handling routes. So we just only need is to pass the HTTP server to the socket server and listen now for these two type of data. Okay, incoming requests in HTTP and WebSocket, right? So this was actually something powerful and interesting, and also how hard is to name things in computer science. So Phil Carton, who works who works for the first web browser ever, Netscape, mentioned that, okay, years ago. So when my dad Phil Carter was working at Netscape, he taught a now infamous phrase. There are only two hard things in computer science: catching validation and naming things. So okay, that's more like a fun fact. Okay, naming things according to Phil Carlton. Okay, uh, yeah, naming things according to Phil Carlton is hard in computer science. It's not only naming things, but also catching validation. So catching validation and naming things are the only two hard things in computer science, according to Phil Carlton, who works uh, who works for one of who worked for the first web browser, or one of the first web browsers, Netscape. Okay, and then looking here at namespace and rooms. Okay, so namespace in computer science allow you to separate concern by encapsulating its logic and expose that. Okay, in an endpoint, for example. But here in this case, two of the most common. So when I look at the chat GPT, right? So chat, open here, right? Chat GPT. Computers Network 101. Nope, no. Here, yes, right. Most common advanced namespace. Or what is namespace in computer science? Exactly, it's a context or a container that is used to organize a group identifier such as variable name, function name, or class name in order to avoid name conflict. Yeah, this is from C Sharp, right? In the namespace, you have this. So this is the way how you access to that namespace. The namespace can be used to organize code with a project or library to prevent naming conflict with other code and to make it easy to understand the relationship between different parts of code. They're fundamental concepts in many programming languages, like including C++, Java, Python, and C Sharp. So namespace, after all, is a context, okay, where it encapsulates or organizes uh, variables, functions, class, in order to avoid name conflict and to make it easy to understand code. So in the context of sockets, okay, so uh, namespace and rooms are two of the most common advanced features from socket.io, okay, where now namespace allows you to separate concern, something that I mentioned here. So namespace allows you to separate concern about socket server by introducing new endpoints that the client can connect for different tasks with different permission levels or completely different applications. But in other words, namespace in socket.io allow you to separate socket server concerns or socket server responsibility by introducing new endpoints. And the client can connect to for different tasks with different permission levels or with completely different applications. Okay, separation of concern. basic. And then I look at how can we do that, right? So for example, you can host a game, for example, multiplayer Pong game and a Tetris game in their own namespace. So now the client can communicate, or now the client can choose which of the namespace can communicate. And this is the namespace where we create. So by default, namespace is set up on socket.io. It is common that we don't need to define different namespace, okay, for simplicity reasons, okay. And here we're just narrowed down when the broadcast to all connected client in our namespace, especially for here. All right, so all the connected client in that namespace will receive this event, right? The start game. And the other concept is rooms, right? And one of the most important advanced feature of on socket.io. So rooms, say we want to create a Pong server that support many users joining and having multiple multiplayer Pong games running at the same time. Okay. So say we want to create a Pong server. Okay, say we want to create a Pong server that support. Yeah, say we want to create a Pong server right now with our multiplayer Pong game. Say we want to create a Pong server that support many users joining and having multiple multiplayers Pong games running at the same time. Okay, so a couple things here. Multiple multiplayer Pong games running at the same time. Many users joining. Okay, so many users joining and having multiple multiplayer Pong game running at the same time. We can create games lobbies which players can connect to a while. Okay, we can create games logic which players can connect to while they're waiting. It's important to use here commas. While they're waiting for the game to start and for another player to join it. And we could communicate with other players in these lobbies and when ready, start a game of Pong. This is all possible with these two features of socket.io such as namespace and runes that are not available with Node.js socket functionality unless you build it from scratch. Unless you build it from scratch. Exactly. So there is several concepts here. For example, lobbies. I am quite familiar with lobbies, but I just want is an example of this. Example of lobby here. So you have lobbies, image of lobbies. Exactly, a lobby. How do you say that in Spanish? La entrada, el lugar de espera. Exactly. Lobbies, really? Vestículo recibidor, hall, grupo de presión in politics. Lobby, presionar, hacer lobby. Presionar o forzar. Recibidor. Vestíbulo. Vestíbulo, weón. Vestíbulo. You know what is funny? We barely use this kind of word. We barely use this kind of word. No, this is a lobby. El recibidor or vestíbulo. As a native Spanish, I barely use this word. Jesus, vestíbulo. Oh my God. Pórtico. Recibidor o zaguán. 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 The term comes from the Arab word Hispanic istawan and started being used as since 16th century, and it is cited by Cristóbal de las Casas in 1551 by Fray Francisco de los Santos in 1657 and appears in many other documents on that time at a time. Interesting. So lobby is a zaguán, recibidor o vestíbulo in Spanish. Okay. So we can create lobbies, vestíbulos in Spanish. So we can create lobbies which players can connect to while they're waiting for the game to start and for another player to join. Again, this is very narrow specific to this multiplayer Pong game, right? So we can create a lobby in which players can join while they're waiting for the game to start and for another player to join. And we could communicate with other players in those lobbies and when ready, start a game of Pong. And this is all possible with these two features of Socket.io, such as namespace and rooms, that are not available with Node.js socket functionality unless you build it from scratch. So rooms are a way of further dividing Socket.io namespace into group of socket instead of dividing the server by separate functionality by endpoints. We instead divide our socket server by a group of clients or socket that are connected. So by default, each socket has its own room. Okay. So with that, that'll be all for this video. Take care. Bye-bye.